being ready or not? Oh, okay. So here we go. If you will turn, today we're going to introduce you to stoichiometry. It's page like 12 or 13 or 14. And it's not as bad. Page 14. No, that's the homework. That's the homework. Sorry, I'm way off. It's probably page 10. Page 10. Okay, a bike. You like that? Stoichiometry, I compare it to parallel parking. Most of you, when you did driver's ed, were probably scared to parallel park. And then one of us taught you how. And you probably thought, well, it wasn't that bad. Did anyone think it wasn't that bad? Sydney obviously thought it was worse. Well, it's okay if you don't like it. But it's not the worst thing ever. You pull up, put it in reverse, crank it right, make an angle, back up, straighten out. Like, in the long run, it's not the hardest thing you've ever done in your life, right? Okay, stoichiometry has a big, ugly name. And it's going to use some things that we learned in chemistry that you probably didn't like before. Namely, the picket fence, zip it, I know you liked it. And moles, which I know you liked even better. Yes. But listen, half of you didn't have me, so I will teach it better. And half of you didn't pay attention who did have me, so pay attention this time, and we'll have a 75% increase. Sound good? Yeah, I've just done this 15 years in a row, and it's the same thing every time. Kids are like, oh, crap. Oh, this isn't that bad. Okay, so first off, we're going to start by talking about a bike. Nice job. You're on the ball. Bike? 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 Okay. All the rest of you, knuckles. Boom, boom. Okay. It's a little weird, but it's really simple to explain stoichiometry through a bicycle. First thing I'm going to do is talk about a bicycle as a chemical reaction. And we're going to ignore everything on the bike except for the wheels and the frame. So a bike is made out of a frame and wheels, and it makes a frame with two wheels. Are we okay with FW2 is a bike? Kind of weird, but that's what it is. Now, this would not work. How come? Tell your lab partner. Because it's not balanced. Thank you, Boatwright. I can't have two wheels if I only had one. So to balance this, what do I need to do? All right. I need one frame and two wheels, and it will make one bike. That's not that hard. Are we okay with that? That is a balanced reaction where we formed a bicycle. All right. Now, all we're really going to say stoichiometry, we're going to make ratios now. So a bike, for every one frame, you will need two wheels. Is that hard? For a bike, every one frame, you can make one bike. It's a 1-to-1 ratio. It's a 1-to-1 ratio. Or for every two wheels, you can make one bike. You okay with that so far? Okay, so that'd be like the recipe we would use if we were going to make a bicycle. How many of you ever used a recipe to cook something? Raise your hands. Okay, if you're not raising your hands, you're weird. Like, you're 16, 17, or 18 now. It's time to cook. All right. How many of you have had a recipe that you've had to double or half or triple? Raise your hands. Okay, that requires a little bit of math, but it's not the hardest thing you've ever done, right? That's all we're doing. Stoichiometry is finding the recipe. The recipe, we don't call it a recipe, we call it a balanced reaction. Okay? That tells us the ratio, that tells us the ratio of things that we need to make the stuff we need to make. But now that we have the recipe, we can upsize or downsize or do whatever we want. So for instance, if you had 100 wheels, how many bikes could you make? 50. That's not very hard, right? And how many frames would you need? 50. That's easy. Okay, what if you wanted to make 200 bikes? Tell your lab partner what these two numbers would be. All right, Boatwright said it nice and loud. 200 and 400, right? Because it's a 2-to-1 ratio every time. So this number is always what of that number? Double. And this number is always what? The same. Because my recipe gave me my ratios. 1, what in the world is happening? 1-to-1 ratio, 2-to-1 ratio. Are we okay so far? Raise your hands if you're all right so far. We find a recipe, and then we change it, but if we have the ratios, we can find out the change of every other part. Okay, now, stoichiometry, it's not as easy as this, but it's not that much harder. So please stick with me. In stoichiometry, we're going to use masses of things. And so it'll say, hey, you know, when they ship me wheels, the maximum amount they can ship would actually be listed as a pound. So let's say the truck can ship 2,000 pounds of wheels. We would want to know as a bike manufacturer how many bikes we can make. And that's different, right? That's different. But if we know one thing, we can do this problem pretty easily. What's the one piece of information? All right, what does a wheel weigh, right? I need to know the weight of one wheel. And then I just plug that ratio in, and then I go to my recipe, and I'm fine. Who's with me on that? Okay, that's over half of you. So in chemistry, we're not using bikes, frames, and wheels. We use chemicals or elements from the periodic table. And we do not find the weight of a wheel. We find what we call the grams per 1 mole. And we'll talk about that word. Please don't be afraid of it. And yeah, my O's are weird sometimes, but I'm over it. Hopefully you are too. All right. Grams per mole can be found on the periodic table. Will you all take your periodic table out and open to the middle, which we haven't used in forever? All right. So let's look at sodium. Sodium has two numbers in it. The 23 is on top, and the bottom is 11. All right. For this entire lab book, we will always be talking about the bigger number in the box. Always the bigger number today. So, if I were talking about sodium, and I wanted to know how much it weighed, like the weight of one wheel, I would simply say sodium is 23 grams per 1 mole. That's what they're listed as. The big number is the molar mass, or the grams per mole. Now, be honest with me. Who hated moles in first try? Okay. I don't know why. Like, I accept it. It's my job. I don't know why people hate moles. It's just a word that means a number. And don't be afraid of it today. Okay? If you had me, we said a mole was a big A number, right? Remember that definition? And what did A stand for? Avogadro. It's just a big number. But for this trimester, it doesn't matter at all what the big number even is. You just have to be familiar with what the number is. And so please read this slide with me. Anytime you have balanced a chemical reaction, you have used coefficients, which we're okay with, hopefully. Coefficients are actually referring to the number of moles that you are using. So they've been there the whole time. Who was scared of a coefficient? No one. 20 of you just raise your hands, you're scared of moles. But they're the same thing. So don't worry, don't overthink, don't give up because I used the word mole and I'm going to use the word picket fence. Just realize I've taught this 15 times, or for 15 years, times 20. This is about my 300th class that I've taught this to, and I'm really good at it. But I can't take you where you need to go unless you'll go with me. You okay with that? So just stick with me. Those numbers, they're moles. So I had this. Let me undo this. I can't. Where in the world? Get out of my way. There we go. So if we had sodium plus chlorine goes to sodium chloride, we would balance it 2, 1, 2. And these are not just coefficients anymore. Tell your lab partner what these are. They're moles. They are, in fact, ratios of moles. Or the nerd way to say that is they are molar proportions or molar ratios. So for every 1 Na, how many NaCls do you have? 1. It's a 2 to 2, right? But 2 to 2 can be reduced to 1 to 1, or 3 to 3, or 10 trillion to 10 trillion. They're the same number every single time. Okay? All right, now this number, no matter what these numbers are, this one will always be 1/2 of the other two. I didn't make that number up. The 1/2 came from 1/2. 1/2 ratio. They are molar ratios or molar proportions. Please don't give up because I used the word mole. Okay? So that's all we need to know. And we need to know where to find the mass, which we'll do eventually today, on your periodic table. And life's actually not that hard. Okay, you with me? So let's fill out this page now. So, balanced chemical equations give us proportions that can be used for predictions. Or recipes give us proportions we can use to make larger or smaller recipes. If you can just think about cooking, it's not that bad. So you have this equation there on page number 10. It's 2, 3, and 2. So, pretty simple. If 2 atoms of S are used, how many SO3s will be made? 2. Will you do the rest of these with your lab partner real fast? Like literally talk to them. All right, here we go. Let's do this. So a lot of people on this next one, they'll write 24, but that's not right. It's just what? 2, because it's already asking for dozens, not 12s. So whatever number is here will always be the same number there. It's a 2 to 2 or a 1 to 1 ratio. If 1 mole of S then, is that legal? Sure, why not? If it's a 1 here, what's this number? A 1. Now, it's going to switch up and talk about different things. If 3 moles of O2 are used, how many moles of SO3 could be made? 2. Very, very simple. Now, it's not on here, but it could have said if 6 moles of O2 were used, what would this answer be? 4. Because if I doubled the one, I have to double the other. It's the same math every time. All right, so here we go. By using moles and molar proportions found in a balanced chemical equation, we can predict the amount of chemicals used in a chemical reaction or whatever it says. So now it's asking you to put the same type of things, but this time in fraction form. So what we do is we just find the numbers and put them where they go. So if you look, mole of S, what number is in front of S? A 2, thank you. Mole of O2, what's in front of that? A 3. Will you do the other two real quick? All right, so these are the ratios or proportions we would use if we were asked for like different numbers than are actually here. So in front of SO3 is a 2, in front of S is a 2. If you reduce that to 1 over 1, fantastic. You can if you want. You don't have to if you don't want. Then moles of SO3 is a 2, and this is a 3. All right. Fair enough? Okay, now let's do what we actually really will do. We're going to convert from moles of something to moles of something else. If you will please follow along precisely, life is pretty easy. Now, I'm going to say a lot of stuff, and there's a lot of steps here, and I definitely am aware that a lot of you can do this exact problem in your head in 10 seconds. But you can't do any of the other ones in your head. So please learn this process while the math is easy. So the process is easy when the math is harder. Please stick with me. I promise that you can learn this very simply if you do what I tell you to do. So here we go. The first thing, if you're ever given one of these problems to do, is balance the reaction. Will you take 30 seconds and try and balance that reaction? When you have it balanced, will you raise your hand and then put it back down? Okay. That's most of you. We'll give you another 10 seconds. If you still can't balance, it is time to worry. For about 5 straight school days, I've had one person come to B time, and they're not even in my class. So I am wide open to help you if you need help. There are also 9 videos on my website on, I said naming, didn't I? I mean balancing. There's 9 videos on balancing. If you would just watch those, that would help. You can come in the morning. I will not be here anytime after school because it's still track season. So morning or B time or my website or your smart friend. All right, so first, balance. So on the right side, there are 3 SO4s. So on the left, I am required to have 3 SO4s. There is only 1, so I have to triple the amount of copper sulfate. Now, that doesn't just make 3 SO4s. It makes how many coppers? 3. So I must put a 3 right there. Now, I still need to check the other part, which was aluminum. There are 2. So I need a 2 right there, and then I'm done. It's 3, 2, 1, 3. Okay, so whenever we do stoichiometry, we first have to find the recipe, or we first need to balance the reaction. All right, the next thing to do, I very specifically want you to follow this. It says start a picket fence with the given number and unit. So I come up to this problem. It says you have 6 moles of aluminum. Lazy people will just go like this. They'll put a 6, and that's it. That does not actually help you in any way. If you put 6 mole of Al, then you're less likely to make any mistake ever. So 6 moles of Al is the number and the unit, please put both, that I gave you. The lazier you are, the more likely you'll get these wrong. Because these are going to get long. We did them in AP today. Wherever I put it. I probably threw it around or away, but it had 5. Is that 5? Like, there was no way you could do this without an organized system to keep track of everything. And that's what this is. This is the picket fence. All right, so 6 moles of aluminum. Now look at the screen. The awesome thing, whether you hated the picket fence or not, first try, it doesn't matter. The awesome thing about it is that you always know the unit here always goes where? Down and over. So on the bottom here you have moles of what? Al. Moles of aluminum. Please, please, please realize these two units always match each other. Always. So we can use that information, by the way. We can use it to go up or down. They have to match each other. Okay, this is getting ugly. I'm just going to erase everything. So once again, 6 mole of Al. Moles of Al. I'm on this part, by the way. Sorry. Next, we fill in the picket fence by canceling units. We're canceling units by making sure that this one and that one match, because then they disappear, right? All right. If you get stuck, go in reverse. So I never, ever want you to guess what goes in one of these boxes, because there is always something that will tell you what goes in the box. So there's nothing written here so far that tells you what goes here. So we go in reverse. What unit do I want in my answer? All right, moles of copper. And please notice something, and I'll say it a lot, and it's annoying, I know that. The unit at the end is the unit at the end. So what goes here? They have to match. Mole of copper. Now, I need to put numbers in right here. Where do I find the numbers for the moles of Al and the moles of Cu? From my recipe, or my balanced chemical equation, right? It was 3, 2, 1, 3. So the thing in front of aluminum is just a 2. That's interesting. And the thing in front of just copper is a 3. And then I do the math. I multiply all the top, I multiply all the bottom, and I divide the two answers. So multiply the top, I get 18. The bottom is just a 2, and then it's 9. Now, we just took 5 minutes to answer a 30-second question. I know that. I know that. But it's going to get a lot harder. So learn it while it's easy. Okay, I want to do another practice one. Do it at the very bottom of that page. So, when we burn propane, propane is C3H8. We're burning it, so it's a combustion reaction. It makes carbon dioxide and water. All right? Now, you're going to balance this, but this is what I want to know. I want to know how many moles of H2O if we burn 50 moles C3H8. That is your question. So you will start by balancing this by following my combustion tips. You will then set up a picket fence with the number and the unit that I gave you. You will then cancel out by moving that unit and number to the bottom right. You will then put the unit at the end, that is the unit at the end, and then you'll do math. Now, Try for 30 seconds to balance it. I'll show you what the coefficients are in a second. All right, I will walk through how to balance it. If you're onto the math, that is fine. Most people in the next couple of days, they will like the math and still hate the chemistry. And that just happens. It does hurt my feelings because I'm a chemistry teacher. All right, the first thing you do is start with a 2. So you put a 2 out front. The next thing you do, according to my tips, is balance the carbons. 2 times 3 means you put a 6 right here. The next thing you do is you take the number with H and you put it in front of water. So you put 8 in front of H2O. The final thing is to balance oxygen. 6 times 2 is 12. Plus 8 times 1 is just 8. So those added together are 20. But I can't put a 20 here because it will be doubled. So I put half of 20, which is 10. 2 10s, 6 8. They are all even. So if you feel like it, you can reduce them. You don't have to, though, because the picket fence will take care of that for you. Okay, that's that. You try the picket fence. All right, let's work through this together. If it hasn't clicked yet, it's fine. Uh-oh, I gotta sneeze. You take the number and unit that I gave you in the problem, which was 50 moles C3H8. You okay with that? All right, then a couple like truths that will never let you down. Whatever unit is here is the same unit that goes down and over. So you have moles C3H8. And while I'm here, the number that goes there came from my reaction. So that's a 2, correct? Oh, don't do this to me. All right, then, I don't want to guess what goes next, because when you guess in chemistry or driver's ed, it's a really bad idea. So what are you solving for? Moles of H2O. So if you ever get stuck and you don't, like nothing tells you to put something there, then go in the back because it will tell you. And then we know that the unit at the end is equal to the unit at the end. This is not working very well all of a sudden. So moles of H2O, moles H2O. And what number was in front of that? 8. Now, some of you may have reduced and you would have 1 and 4. Does your calculator care? No. But, you know, be smart. If you have an 8 over 2, reduce it so you don't have to do anything in your calculator. What's 50 times 4? 200, right? Okay, who had 200? Oh, you guys are amazing. Hey, I even see smiles. That's a good sign. This is not that bad. It's a pain in the butt. I know that. But I have to teach it to you. And it's actually an extremely useful tool if it clicks to the level where you know you can use it. Because you can use it a lot. My biggest person that's ever come back and told me thanks, she's a manager of a Kneaders in Salt Lake City, a bakery. And she's like, the first thing I do whenever I hire someone is teach them stoichiometry. And that's so that their recipe for a dozen can be made for 10,000. They know how to do all of their conversions. There you go. All right, there are problems in your homework. Would you please turn to page 14, I think? Number 36 on page 14 says, how many moles of nitrogen monoxide? That's the NO, okay? So you're solving for the NO. Can be made using 5 moles of oxygen in the following reaction. So first balance, then do your picket fence. And I know, by the way, half of you already know the answer is 10. I know. Don't care. Please do the process. Nice work, Ronald. Okay, when you're done, check the screen. See if you concur. Most likely, if you got anything wrong here, it would have been the balancing. And not even the balancing. Most of the time on this problem, you just put the wrong things in the wrong places. So, like, you don't know what nitrogen monoxide is or something like that. Okay, the next one, the chemistry and the math are very simple, but I will help you. The next one is a double replacement reaction between HCl and NaOH. In a double replacement reaction, this first part switches places with that. So the two products I'm left with are NaCl and HOH. Every single piece of that reaction is charged positive or negative 1. So there are no coefficients. Subscripts, which means all the coefficients are 1s. Which means that you're going to do a picket fence for absolutely no reason. But will you please try to do it? It's to practice the process, even though the math is dumb. You're going to multiply by 1 and then divide by 1. I know, but we're learning a process. All right, most of you were ready to roll. So we have our given was 25 moles of which thing? HCl. So what unit goes on the bottom? Mole of HCl. The good news here is you could screw up royally and it wouldn't matter. HCl, what are you solving for? NaCl or HOH? NaCl. All right, and that's moles. So the unit at the end is always the unit at the end. So mole, NaCl, they're both 1s. So our 25 moles of HCl in this reaction are converted to 25 moles of NaCl. Okay, the next one is gasoline. C8H18 plus O2 goes to CO2 plus H2O. This is what type of reaction? Combustion reaction. I know it is because it has just C's and H's. It's just reacting to oxygen. It is just producing CO2 and just producing water. Okay, follow by steps to balancing. I don't know. I hope that we can get these. If you need help on the balancing, you start with a 2. Balance carbon. Take the number with H, put it in front of water, and then balance your oxygen. 16 times 2 is 32, plus 18 times 1, that's 18. You add those together, you get 50. Divide that in half, you get 25. All right, check my work. I started with 150 moles of octane in the top left. Oh, that's funny. I put a 3, but whatever. This is an 8. I took the moles down to the bottom because this unit that's here always goes down here. I brought this 2 because that was the number in front of those, and that's what moles are. And then the unit at the end is CO2, so I brought CO2, and that was a 16. I reduced 16 halves into 8 and multiplied them and got 1,200. Who had 1,200? Raise your hand. All right, not that bad. We will, let's turn back to the notes, and we'll talk about the next piece, which we'll do today and tomorrow. So if you leave here not understanding the second part, that's acceptable. All right, so what we just did is I gave you moles. So you had your moles given, and I asked you for moles wanted. That's the step, that's the process we just did. What we're about to do, I'm going to give you moles, and I'm going to ask you to solve for grams wanted. So that takes 2 steps, or it takes a picket fence with 2 vertical lines. And I'll go over this a lot in the near future. So here we go. Please balance this on page number 10, right at the very bottom. When you have that, raise your hand and put it down. Okay, most people have raised their hands, and I'm running out of time. This vibrates every time, so we're right there. So, since there are 2 H's and 2 Cl's, all I need is a 2 right there. 1, 2, 1, 1. Okay, now we're going to do the picket fence. So I do the same thing. I take the number and unit that was given to me, and I start the picket fence with it. So 1.8 moles of HCl, so I put 1.8 mole, and I make sure to bring the chemical, which is HCl. The reason why is if I know what is here, I know what comes down here, right? So the bottom of the next one has to match it, so I know it is mole of HCl. Now, I do not know, well, I do, but there's nothing right now that tells you what goes up here. So what do we do if we get stuck? We go in reverse. So you come over here. The problem is asking you for grams of what? H2S. And what do I know about the unit at the end? It's the same as the unit at the end of the picket fence. I don't know where that word came from. It's H2S. Now, I do need to teach you something very important. Anytime you're given grams, it's always per 1 mole of the same thing. So if I have grams H2S on the top, it is per 1 mole of H2S. Okay? Now, please look at the screen. If I know the bottom right unit, I also then know that it goes up there. So up here is moles H2S. And now I have all the picket fence filled out. I just need some numbers now. So the mole over mole, I just find that up here. So what's in front of HCl? A 2. I know this is ugly, but we'll be all right. What's in front of H2S? A 1. And then the last box to fill is the grams of H2S. So now I need my periodic table. In the middle, H has a molar mass of 1. But how many of them are there? There's 2. So that equals 2. Plus, S has a molar mass of what? Over on the top right-ish. 32. How many are there? 1. So that's 32. You get 34 when you add them. What was that, Mumble? Did I scare you? So that means it's 34, but it's not just 34. Oh my. It's 34 grams per 1 mole. Well, we already have the 1 mole, right? So we just put the 34 right here. 1.8 times 1 times 34 and divide that by 2. Okay? Multiply all the top, multiply all the bottom, and divide. So 1.8 times 34 divided by 2. That's 1.46, is that right? 1 point what? Oh, 30. Okay, the next one we do is that answer. 30.6, thank you. Hey, the one in your homework is going to be 1.45, in case anyone cares. Okay, I don't expect that that one was perfect, but we will do multiple ones of those tomorrow.